Data Skeptic is the official podcast of dataskeptic.com, bringing you stories, interviews, and mini episodes on topics in data science, machine learning, statistics, and artificial intelligence.
Deb Ray is the CTO of EndQ, where his team of data scientists and engineers are building the company's AI platform for analyzing and generating original content. Previously, he was the Chief Data Officer for VideoAmp, where he continues to serve as an advisor. Prior to that, he was the Chief Scientist at Pasadena Labs, a company he founded during his doctoral studies that built machine learning-based applications for clients like Microsoft and IAC. Deb holds a PhD in machine learning from Caltech and completed his undergrad from the University of Toronto, where he began doing research in deep learning and computer vision in Jeff Hinton's group. He has been involved in the field for over 10 years. He is currently a fund advisor and investor at the VC firm SignalFire, and angel invests in AI and blockchain startups. Deb, welcome to Data Skeptic.
Thank you very much for having me, Kyle.
So you'll be speaking, to kick things off and promote this a little bit at the upcoming conference that we're having. Can you give me a few details about what you're going to talk about?
Yeah, I'm really looking forward to the SoCal Data Science Conference. I'll mainly be talking about some of the efforts at EndQ in using generative models, in particular generative deep learning models, to create original content.
That's October 27th in Pasadena, California. I'll have some links in the show notes for anyone who wants to check that out. Good line of other speakers as well. I hope you come here, Deb, and many of the others too. So there's many areas you and I could get into today. I thought it'd be most interesting to open up talking a little bit about EndQ. Can you tell me some of what you guys work on there?
EndQ is a reimagination of film production company. The founding team is filmmakers as well as VCs who have been in Silicon Valley for, over 20, 30 years. I recently joined EndQ because I wanted to lead an initiative on bringing technology, especially AI, machine learning, some of the advances in VR, into the film production process. But the advantage of doing this with EndQ is there is a lot of production expertise. Film production is an art, and that is, we have a head start in the production space by working within EndQ and leveraging the expertise in-house as well as the industry contacts.
Yeah, I'm starting to see a lot of interest in this space. It seems historically Hollywood was thought of as an artistic thing, and of course it is, but many people have the opinion that if something's artistic, there isn't much a mathematician can do to help with it. How has that been changing in recent years?
It's an interesting point. I got into, so after my PhD in machine learning, I got into the space of advertising technology because there's a lot of behavioral data, and it's a great place for a machine learning person to be in. But the core thing there was what really drives advertising is content, the underlying content. For the longest time, the content was supposed to be something that was generated artistically. It's a creative process and so on. We wanted to take a closer look at that, and especially because I'd seen some of these methods in deep learning where you could generate novel hypotheses, generate text, generate images. So I started thinking about how could these be applied to filmmaking. And furthermore, in the film space, the whole production aspect, that is something that you start with a script, which is pretty much like the blueprint of a project. And then it takes on a project management scope from there. You're trying to optimize people's schedules, minimize budget. There's tons of variables, like where they're going to be like at a particular day. There's financing involved. So there's a lot of variables in the production space as well. And that's another place where I saw the opportunity to apply AI to optimize film production as well, to decrease budgets and timelines. So really now at EndQ, what we're trying to do is bring tools to help creatives and producers create much better versions of the products that they would have created without us. Analogy I'd draw is AutoCAD. Not too long ago, field of architecture, that was supposed to be just a very creatively driven endeavor. But these tools for visualizing and machine learning and all these things came in to the field of architecture so that you could take ideas that architects had and supercharge it, help them create much more complex versions of what they had in their mind, and also take away a lot of the tedium. So that's what we're focused on.
And in terms of those tools, what does that end up being as the end user? Do I log into some system? How do I engage with NQ if I'm a movie producer?
The external facing products that we have now, one is the story writer, where you could be an amateur story writer or a professional story writer. You could use our story writer platform to upload a script at any stage, even if it's an unfinished one. First, we visualize it. We extract all the elements of the story. We construct character interactions, story arcs, help you visualize your story. With the aid of that visualization, you can easily identify places that need more development, if there are any particular holes in the script, and so on. Then the step beyond that is if you go in and change a certain variable, let's say a character interaction, or you introduce a new character, how does that affect the rest of the story? And then furthermore, we plug in our generative models in there so we can actually generate pieces of a script, or we can generate dialogues. It gives you the ability to take a story that you've just thought of and turn that into a much more better fleshed out, complete script. So that's the story writer part. On the production side, studios have a lot of these tools, but independent producers don't have access to a lot of these, where you can take your script, extract the core elements. From that, figure out what are the budget aspects, figure out the scheduling, generate call sheets after optimizing all the variables that go into your production. That's the production optimization tool. And finally, and this is something that we use internally, we have thought about maybe exposing it or offering it as a SaaS-based service, is we can go from script and pretty accurately look at outcomes in terms of budgets and production schedules and so on, and tie in data about performances or predicted box office or predicted distributions. We can go from end to end, from a script all the way to potential revenue and costs according to different distribution channels. So now we get an end-to-end model where we can look at lots and lots of scripts out there and see the outcomes. And if we like the outcomes, we can exercise options to buy scripts. That way we enter or get into the funding side of this. That is a tool that we have used internally, and that's one of the reasons why a lot of the productions that we've done at NQ have turned out to be very profitable.
So a lot of stuff for us to get into. I think maybe it'd be interesting to unpack the last one first there, the trying to take a look at a script and figure out which ones you might want to fund. And even, did you say you were potentially predicting box office revenue from the script?
The idea of predicting box office revenue from a script is not something entirely new. Even in the current state of the art, people look at scripts, they go through breakdowns, they put in variables like who the talent is going to be, where is this going to be shot, the location, genre, and so on. And that goes into a macro model, and with predictions on box office performances or whether it's likely to get distribution in Netflix or Amazon or various different channels. And we all know that obviously filmmaking is not an exact science, and some of these macro indicators don't really work that well. It's a constant effort then to introduce newer and newer variables into this. Where we can come in is actually looking at the scripts, evaluating the quality of writing, the character interactions, but also looking at the production process itself. How it would typically work at studios now is they'd greenlight a project based on the script and these macro variables. Then it would go into a production stage where then there's a script breakdown, budget estimates, and so on. It adds another 2 to 3 weeks to that process. We automate that process, bringing it much further upstream. So at the development stage itself, you have a much more accurate model of what the likely budget an outcome is going to be. So you're making much better decisions early on.
So in terms of making a prediction like that and determining, like what to fund or what it might end up generating in the box office, it's interesting. I think if it were day one and we were starting that project from scratch and I was to tackle it, I would come up with some heavily engineered features like, how big of a star are the various people, who's the attached director, some of these really high-level things that certainly have predictive power. But I don't think I'd get very far with my little logistic regression. I'd probably get a very small R-squared. There must be more sophisticated things you're looking at. Like you'd mentioned quality of writing. But I would also say that I don't know that every box office hit necessarily is known for its great literary accomplishment. Sometimes they're just, fun or like you said, it's unpredictable why some things succeed. How do you go about modeling that? What more sophisticated things can you look at beyond what the actors and actresses are and those sorts of details?
It's a very good question. I mean, we do consider those macro variables like the genre and the performer and so on, because those add to the final outcome quite a lot. For example, the lead actor has a huge effect on the outcome of the movie. But where we can add a lot more data from the script process itself is by using deep learning models. That's what we had to use on our side when we did our generative models when we want to create original content. So we use those models as well in a regression sense to come up with scores for different for a script itself. So those add into variables, and there are a lot more variables that we can extract with those models. And then we add in the production elements. So now we're dealing with a lot more variables than what you might fit into a regression model.
You guys are involved in producing this, it's not a biopic, but a movie that stars a fictionalized version of Michael Jackson. Of course, anyone who reads the script can understand that. I, as a person, I'm culturally aware, I know who Michael Jackson is. And I know that that's going to be more successful to the same movie made with a generic character because you're bringing his personality to life and he has a fan base and all that sort of thing. I don't know that that's something the deep learning network would figure out just looking at a script. So I'm curious, how much of a movie is predictable in the data you have available?
I would say about 50% of the variance comes from the script and the resulting production. The script itself ends up affecting the character interactions. When movies are released, that people love to point out holes in the script. Also, the script affects the ultimate production and therefore the budget, right? So you can, choose to take out certain elements of a script to reduce the budget, but how does that end up affecting the overall score of the movie? So those are, I would say, contributing to roughly like 50% of the variance typically. There's also additional data that we use, like distribution data. What is the likelihood of getting distribution for a certain film, as well as search data. So search trends and Twitter data. So we're putting in a lot of data into these models.
I would imagine, though, that you have a relatively small data set. I know a lot of movies come out, more so than even I'm probably aware of, but you have fewer records than you ever had on the ad tech projects you work on, I imagine. To even do cross-validation, you probably have to be choosy about how much of your set to use for holdout or not. Do you bump into issues with low sample size just because there are a finite number of movies made?
Not only low sample size, but you also have a sample selection bias if you're just looking at movies that are, in the public domain or that have been made.
Oh, good point.
So if you're just training, your deep learning model using movies that have been made and then run that against box office data, that would be heavily skewed and have a huge sample selection bias. Like by far, the majority of the scripts never get made, right? So we do control for that because we look at scripts that are, and we've inserted ourselves into the various points of the ecosystem to be able to collect this data, where we look at scripts that are under development by working with different partners. We also look at scripts that have never been picked up. So we have a much bigger sample of scripts that are out there. And then a small fraction of them are the ones that are actually being considered, and an even smaller fraction of them actually get made. So that's one way that we are looking at a much bigger data set to control for some of these biases.
Gotcha. But then what's your objective function on the movies that were written but never made?
That's a very good question, because ultimately, there's not only the box office successes, but you also have the aesthetics, the creative decision.
True.
For that, we are limited by our network that we have created where we have annotated data and we have collected data internally. So people have gone through scripts, annotated parts that they have liked. So we've collected a lot of human trained data.
I see. Yeah, that's the key right there, I think. Correct?
That's right. Obviously, there's limitations in collecting that data, but that's really our advantage. We realized early on that in order to do this well and in order to solve this really hard problem, we had to create data sets or tap into data sets that other people don't have access to. And so that's why we had to annotate a lot of this data ourselves internally, and it's an ongoing project where we collect data from multiple sources and then annotate it with amateur and sometimes, when we can access it, professional writers.
Very interesting. Yeah, that was going to be my next question, that the annotations are very interesting to me, because if you get someone to be an annotator who is exceptionally good at spotting hits, well, then the machine learning is pretty easy. But I would be surprised if any one person existed who does that. So maybe you're tapping into wisdom of the crowds, or maybe your system is even learning under what conditions do certain annotators provide useful feedback. Do you have any sort of black box sense of how your algorithms take advantage of those annotations?
Yeah, so a general mechanical Turk approach doesn't really work here, because you can't just distribute it on Amazon and come back with a bunch of annotations, right? There has to be some expert data involved here. But to a large extent, the wisdom of the crowds does work. I mean, that's one of the reasons why when you look at films and film predictions, critic ratings do not necessarily correspond to how successful the film is. When we looked at our annotators and how successful or how useful their annotations have been, we don't really need a large number of samples from expert annotators or top critics out there. The wisdom of the crowd does help a lot, because ultimately part of the measure we have is how well liked the script would be in the crowd.
And how has Hollywood responded to the idea that you could predict or maybe rank order whatever your deliverable is, but give them direction on what they should fund or work on? It seems to me that there are a lot of people who, maybe in the interest of protecting their jobs or due to their high confidence in their abilities, might say, no machine can help me here. Has there been wide acceptance or any resistance to the services you guys offer in this way?
Some of the early attempts of bringing in AI into the creative space, a lot of the earlier inventors made a lot of big claims. As a result of that, naturally people tend to think, well, either the claims are exaggerated or there's a threat to the creative endeavors because of AI. None of that is really true. I mean, ultimately, art is an aesthetic endeavor. The success of how good a piece of art or writing is depends on the observer. So it's a subjective measure. It's not a typical way where we can define an objective function. That's why if we are going to develop these methods, we ultimately definitely need a human in the loop that's guiding this process and helping the machine learn about what's good aesthetics and what's not. We have realized this, and the way we position ourselves, it's a creative endeavor. Our tools and our methods come in to take away a lot of the tedium and also take a creation and make it a lot more complex. An example of this is interactive video games, where based on the choices you make, the stories can change. So in that case, or even take the example of TV shows like Game of Thrones, where there's been a lot of character interactions over many, many episodes. So both reflect really complex storylines. And that's one place where people have to rely on these tools to make their writing a lot better.
So we've talked a lot about script analysis and some of the funding and things. Let's get into going the other direction, generative models. Everybody, want to take a quick break from the show and tell you about one of our sponsors, Periscope Data. Periscope Data is perfect for data teams. Anyone that knows SQL, just basic SQL, select from where stuff, they'll be able to master this tool instantly. Are you doing visualizations in Excel? Geez, you got to get past that. Even if you're doing something a little fancier like some matplotlib stuff, check out Periscope Data. You can quickly and easily build these interactive charts. They have really intelligent defaults. If you get asked a lot of analytical questions or you want to do a lot of quick analysis, I can't imagine doing that without Periscope Data. And then once you build stuff, it's in the dashboard. It automatically resyncs to new data so you can follow all these things you've looked up one time as trends in the future, organize them into different dashboards that you share with different collaborators. If your collaborators can use a web browser, they can definitely use Periscope Data. Very easy to use, very slick. See if it's right for you and your team at periscopedata.com/skeptics. So we've talked a lot about script analysis and some of the funding and things. Let's get into going the other direction, generative models. And in particular, I guess we should start by talking about Sunspring. I think probably every listener is going to already be familiar with it, but just in case there's someone out there who wasn't, can you share the story of how Sunspring came to be and what the final production was?
So Sunspring was definitely an experimental effort by NQ. It was taking a very, what I would say at this point of our development, a very rudimentary model based on a long short-term memory with a maximum likelihood objective function that could generate text in the form of a script. What captured a lot of people's fascination was taking a script that was produced by a deep learning algorithm and converting that to a film. Now, there's a lot of effort and I think some excellent direction that went into taking that script and turning that into something that was watchable and people actually liked it. So the process was, at that point, it was a text generator, a long short-term memory text generator. It was produced in a very time-constrained manner. So it was produced within a space of 48 hours because it was produced during a competition.
The film itself was, right? The script was written in advance?
The script was also generated during the competition.
Gotcha.
I think that part shouldn't be forgotten. So taking all these together, it was definitely quite an effort to produce the ultimate film within the time constraints, but ultimately people really liked it. Now, the storylines and the scripts wasn't completely coherent. So when I talk to people on the film side, for them, it's quite fascinating because the script was generated by AI and it was ultimately produced. But, computer scientists tend to be harsh critics of themselves and other methods, myself included. So, when I talk to other computer scientists, we obviously dived into how can we make this better? How can we make future scripts more coherent? And it was ultimately really good because it sparked a dialogue. It helped us push the technology forward. And that was really the starting point. And now we made a lot of improvements since then.
Oh, interesting. Can you go into some of those advancements?
Maybe I can give a little bit of a background, especially on generative models. So generative models model the joint distribution of the input and the output. So what you can do is you can sample data because you've modeled joint distribution. And so with the some of the early works you might have seen with generative deep learning models, include the images that were generated with TensorFlow. They have this crazy hallucinatory look to it.
InceptionNet, right?
Right. So that was in the case of images, right? And then beyond that, then came generative adversarial networks. It moved from creating these alien-looking images to something that was much more sharper and closer to the training set. So the images, and also there's been some work on generating musical pieces as well as sounds. So a lot of the advancements that have happened have been in the domains where you have a continuous input space. Language is different. And language is a lot harder because language works in discrete spaces. What I mean by that is, if you take an image and a color, like a red color, and you move in a slight gradient, then you get some version of a red. Or if you have a circle and you move in a slight gradient, it's still, like a circle. That makes the objective function different, and you can do a lot of gradient-based methods. Language doesn't quite work like that. If I have a sentence like, my cat is cute, then if you take the word cat and just do one gradient move and turn the C into a B, my back is skewed does not make a lot of sense.
Mm-hmm.
So a lot of the optimization methods that worked for images and music and a lot of these continuous space models don't work when it comes to language. In language, you're evaluating the entire output. So that's one of the things that we had to do. We had to move away from a lot of the objective functions towards using different search techniques like beam search, and then also evaluating the entire sentences, which require a whole different apparatus. That's why I would say language is also harder. And at the same time, for language, you do need a decent size training corpus to really understand whether what you're generating is good or not. So those are the two places we had to start. Furthermore, generative adversarial networks work really well, again, with images, because when GANs started, the purpose of GANs was to produce sharper looking images. So what it would do is a GAN method would go and explore the space and try to hone in closer and closer to the maximum. That's not the case when we're dealing with language, because I could say two different sentences and have similar meaning. That's why we started looking at more autoencoder models or variational autoencoder models that have been more successful for our purposes.
Yeah, can you tell me a little bit more about those? I think that's one of the keys to the work you guys have done, right?
With the variational autoencoders have been used quite a lot in neural machine translation. Neural machine translations also, another technique used there is sequence-to-sequence models. So an autoencoder takes an input could be in a very high dimension, and converts it into a low-dimensional space, but its own representation.
Mm-hmm.
To give you an example, let's take a sound. The sound could be a bird chirping. So on the waveform level, which could be the input, there's a lot of different variation there. But underneath, the representation that's learned is just a bird and chirping. So if you look at, you break it down into kilohertz representation, it's a much more compact representation. That's, in a lot of senses, that's what our brain does as well. It takes an auditory input, and then our auditory cortex converts it into a much more compact representation. And then there's a decoder element to that. So once you want to produce new samples, you say something, so it emerges as a point in that low dimensional representation. Then you take the inverse process. So you go from what a bird song might sound like to the actual waveform. So it goes through a process of first compressing and then decompressing. And the variational part basically means that this objective function is really hard to write down because it's multimodal and high dimensional and so on. So one way of doing that is by using, sampling methods like Markov chain Monte Carlo methods. But that's computationally very expensive. So instead, you approximate it with much more tractable distributions like multinomial Gaussians. So that is the variational part of it.
Got it. Makes sense. And why do you think it's that formalism that's worked so well in your applications?
The reason for that is with language, as I said, with language, there's a thought and then there's an expression. So there's multiple ways I could express a particular concept. So my core concept could be, I want to talk about cats because cats are so popular on the internet. Mm-hmm. Every example has to come from that. So I want to talk about cats. So now there's different sentences I can construct about that. A cat walking down the road, a cat meowing, and so on. So you go from concept to all these forms that are a representation of it. Similarly, when you look at a whole bunch of sentences, you're trying to extract more low-dimensional representation. That's the encoding part. And when it comes to decoding, you want to go from concept to expression. So that works pretty well for languages.
So I was really glad with the way you framed the whole Sunspring project. I thought it was really neat, but also you take it in context. As you point out, coherency wasn't its strong suit. I don't know that it would have gotten the same attention if a human author had written it, although maybe David Lynch could have written it and that would have been typical or something like that. But I think it's a great thing to celebrate in the sense that it's a breakthrough. It was a first. It was a pioneering effort in a script that was generated entirely generatively. And of course, a movie is the contributions of many things. The actors, the directors, all those people came together to do it. But it's the first of many, I think, scripts that we'll see either written in combination with a human or perhaps eventually we'll have an entirely automated script generated. I think there's probably some innovations from what we have today in terms of the tools we use to do deep learning and what it would take to do that. Because like when I think of a story, could a neural network complete my sentences for me? Sure. Could it come up with a bunch of characters, develop their relationships, create a story arc? This is a lot of sequential connected things that have to be put together. Do you think it's a matter of just throwing more neurons at it, or do we need to invent new ways of doing deep learning to achieve that ultimate goal?
So we do need new architectures to do this. It has to take a hierarchical representation. So when you're talking about one concept could be embedded in a sentence, but then if you want to be coherent in a whole paragraph, you need one level, hierarchical level. If you want to be further more coherent, about a character across paragraphs, that requires another level. Hierarchical structures are very important here. Also, for deep neural architectures, having an external memory makes the process much more efficient. Mm-hmm. So now, if I can remember, or if the neural network can remember what was said in 52 pages ago, and then be part of a search function, then you can continue on that same vein. So that's an example of with murder mysteries, right? In the early part of the movie, you could have a knife placed under a desk. And that's used later on at the end of the movie, right? And that's the key element. So that's what the external memory helps with, being able to query in a much earlier part of the script. So that's what we're exploring now. We have created, we have new productions since Sunspring. I can't go too much into detail there because it's going to be submitted to some film festivals. But the part that we wanted to emphasize was not so much look at this script that was generated by AI and then there's a certain novelty to it, but where does it actually make sense to use these tools? One of the productions that we have is in a future where humans have to interact with AI. I mean, every day we're doing that. We're talking to our Echo or Google Home at home. As these devices get better and smarter, what might those conversations look like? So that's one take of it. The other production that we're working on is we're going back into films that have been very successful, but where they have used an AI character, like Star Wars is a lot of it, or Mystery Science Theater, where the AI dialogues have actually been written by humans. So that's not very authentic. So what happened if we actually tried generating AI to, using our models to have actually those AI character dialogues being generated by AI? What happens then?
Yeah.
So these are the things that we are working on right now and should be released in the near future.
Where's the best place for people to follow NQ and some of these things as they start rolling out?
You can follow our Twitter account at NQ. I'm also on social media at Deb Ray on Twitter as we come up with new projects, both AI generated as well as that are kind of a output of our internal models that we've used. We post about it regularly. It seems that some of our productions seem to be picked up by media because it's very topical. Definitely. So would likely be in the news as well.
Excellent. Well, Dave, I really look forward to watching that coverage and seeing what you guys are doing in the future. Also looking forward to hearing your talk at the upcoming conference. Once again, anybody who wants to check that out, it's going to be in Pasadena on October 22nd, the Southern California Data Science Conference. A link to that and many of the other topics will be in the show notes. Dave, thanks again for joining me today. This was great.
Thank you very much, Kyle. Thanks for having me here.
Data Skeptic is a listener-supported program. To support the show, visit dataskeptic.com and click on the membership tab.